There is a star drifting through our galaxy right now that has no right to be where it is, or moving the way it is moving. Nothing about it belongs in the part of space it currently occupies. By the end of this video, you will know exactly what that means, without me giving it away yet. Picture a point of light that existed before the Milky Way had spiral arms, before the sun, before Earth was even a cloud of dust circling a young star. Now picture that same point of light moving right now at over 500,000 meters every second. Fast enough, maybe, to leave our entire galaxy. Forever. Here is what astronomers thought they understood. When a black hole at the center of a galaxy tears apart a pair of stars orbiting each other, one star gets swallowed. The other gets thrown at incredible speed out into the galaxy. Astronomers have had a name for this since the 1980s, the Hills mechanism, and they have caught stars doing exactly this before. Every one of them was young, heavy, the kind of star that burns fast and does not live long. Then, earlier this year, a research team led by astronomer Shunhong Dung found something that does not fit that pattern at all. A star cataloged as DESI-HVS1. Its age, 14.1 billion years, give or take a billion. The universe itself is 13.8 billion years old. Do that math, and within the margin of error, this star is almost exactly as old as the universe. And something at the center of our galaxy just threw it out. Nobody was hunting for it specifically. It turned up almost by accident, buried in a massive spectroscopic survey called DESI. Its chemistry gave away its age before anyone even ran the numbers on its speed. Its iron content is roughly 40 times lower than the Sun's. That is the kind of chemical fingerprint left over from the first few generations of stars the universe ever built. Back before heavier elements had time to accumulate. This star is a leftover, and leftovers are not supposed to be moving like this. Start with where it has been. Astronomers traced its path backward through the galaxy, and the trail leads directly to the center. 12.89 million years ago, it passed within about 1,300 light-years of the black hole there. The galaxy itself is roughly 100,000 light-years across. On that scale, 1,300 light-years is not a near miss. It is practically a graze. At that distance, moving 682 kilometers per second, something ripped its companion star away and kept it. DESI-HVS1 got the exit. And this is where the story stops making easy sense. Compare it to S5-HVS1. A hypervelocity star found back in 2019, flying out of the galaxy at over 1,700 kilometers per second. Young, heavy, bright enough to catch from clear across the galaxy. That is the profile everyone expected to keep finding. Old, small, faint stars almost never show up in these searches. Mostly because they are too dim to catch, not because the physics forbids them. Statistically, there should be plenty of them out there. Nobody was catching them. This is exactly what I meant at the start. Nothing about this star belongs where it currently is. So how did a 14-billion-year-old lightweight end up paired with a partner in one of the most violent places in the galaxy? Nobody has a clean answer yet. One idea researchers keep coming back to is old, dense star clusters called globular clusters, packed with exactly this kind of ancient, low-mass star. Maybe this one spent most of its existence in a cluster like that. Then slowly drifted toward the one place in the galaxy capable of throwing it back out. It is a plausible path. Dung's team is careful to call DESI-HVS1 a candidate, not a confirmed hypervelocity star, because that path has not been nailed down. The mechanism that flung it is well tested. What got it into position for that mechanism to work at all is what the paper leaves open. Zoom out far enough, and the Milky Way stops looking like a fixed structure and starts looking like something that is constantly leaking. Stars get flung from its center on a regular basis. Most of them are moving too fast or burning too faint for anyone to have caught them yet. DESI-HVS1 just happened to be the one we noticed, which raises an uncomfortable question. How many more ancient, unremarkable relics are already out there, halfway to somewhere else, that nobody has looked at closely enough to catch? I keep coming back to the timeline more than the speed. This star has been burning quietly since before there were galaxies shaped anything like ours. It survived nearly the entire history of the universe, sitting somewhere unremarkable. And then, in the last 12 million years, a blink by its own standards, everything changed. Remember that 500,000 meters per second from the start of this video. That number was 523 kilometers per second, dressed down so it would not give itself away too early. It is close enough to the Milky Way's escape speed to matter. Dung's team puts the odds somewhere between 30 and 50% that it eventually leaves for good. 50% or 30? Somewhere in between. Not certain, not ruled out. A slow-motion coin flip playing out over millions of years. Even the odds depend on which map of the galaxy you trust. Heads. It drifts forever into the empty space between galaxies. Tails. It falls back, still carrying that ancient chemistry with it. That point of light was already ancient before the Milky Way had the shape we recognize today. Right now, nobody knows which way the coin lands. It might already be gone. Thanks for watching.